Okay, so we're solving quadratics with the quadratic formula. Okay, so this is the quadratic formula, negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Okay, I don't know if any of y'all have ever had to memorize it, but the Jack in the Box theme song, or not theme song, like the Jack in the Box, you know, the like spin it. Anyways, okay, will totally help. I won't sing it for y'all because I promise y'all don't want me to, but okay, one thing I do want y'all to realize is that this b is opposite. Why is it going to be opposite? Because it has that negative in front, okay? And that negative makes it opposite. So if you plug in a positive 6, it becomes negative 6. If you plug in a negative 6, well, 2 negatives makes a positive, so you end up getting a positive 6. So if you're ever trying to work backwards, just know that this b is always opposite. Now this b, if the inside of this is not simplified already, is normal. Also, your key to simplifying these is to simplify what's under the house first. Now, don't include the house, just what's inside of it, okay? Because if it's negative and you type it all with the house, it's just going to tell you error, okay? And if it's not a perfect square, it's going to tell you some ugly decimal, and you're going to have to go backwards anyway and figure out what it is to simplify it. So it's just easier to get in the habit of just typing what's under the house and simplifying that first. Okay, so this is to find x-intercept solutions, roots, and zeros. I want y'all to know all of those words mean the exact same thing. Okay, and this method always works. So if you don't ever want a factor to solve, you can always use this method. Okay, if you don't want to use a square root method, this method always works. Okay, use the quadratic standard form, y equals ax squared plus bx plus c, to find your a, b, and c. So this first one is, we're going to kind of work backwards. It's already plugged in for us. Okay, and the first question says, what quadratic equation was used to plug in this quadratic formula? Well, if we want to know the quadratic equation, that's the ax squared plus bx plus c, we need to find our a, b, and c. So remember, this is negative b plus or minus b squared minus 4 times a times c all over 2a. So what is my a? 2. And what's my b? Positive or negative? Positive, because remember, this one's opposite. And then c is what? Negative 7. So what will my quadratic formula be? Or not quadratic formula, quadratic equation. 2x squared plus 13x minus 7. Yeah, you did do this in Algebra 2, you did this in Algebra 1. I don't know what you do in geometry, so I can't talk on that. But you did do it in these two classes. Okay, so what are the solutions to the equation? So that's where we're going to simplify. So like I said, we want to simplify just what's under the house first. So you're going to type that in your calculator. Just the way you see it, parentheses and all. Just don't include the square root. And what does it equal? 225. So I'm going to simplify this. So I have a negative 13 plus or minus the square root over, what's 2 times 2? 4. Okay, and I just simplified inside the house and it was 225. Is 225 a perfect square? If you're unsure, you could do second square root 225, and it is a perfect square. So what does it equal? So we could negative 13 plus or minus 15 over 4. Now, if you notice, the plus or minus is already built into the formula because we took the square root of a number, right? But the plus and minus is already there, so you don't have to worry about that, okay? So we can separate and simplify. We get negative 13 plus 15 over 4, and negative 13 minus 15 over 4. Well, what's negative 13 plus 15? 2. And what's 2 over 4 simplified to? Now what's negative 13 minus 15? Negative 28 over 4. What does that simplify to? Huh? So there are my two answers. Huh? Do what, like what? On this one, you could have. But on the next two, you won't be able to. So that one was just kind of a practice, yes.
How did it get to
225? I typed just what was in the house. So this 13 squared minus 4 times 2 times negative 7. So I did not include the house in that. I just did what was under it. Does that make sense? Okay. Any other questions on number 1? Okay, so let's look at number 2. So now nothing here is set up. It's just giving me my equation, which means what should I figure out first? Huh? A, B, and C. So A, B, C. And it's already, like I can already set it equal to 0. There's no numbers on the other side of the equal sign. And what is my A? B, and C. So then I remember, I don't know if you remember, but in Algebra 1 and Algebra 2, we called this the skeleton because it has all the bones of the formula, but it doesn't have the insides. So negative b plus or minus square root of b squared minus 4 times a times c all over 2a. See how I didn't plug in any of the letters? And I did that so that way I can plug in the numbers now. So this is b, b, a, c, 2a. So 8, 8, 1, 1, and negative 11. So this becomes negative 8 plus or minus square root of something, and 2 times 1 is 2. And now I'm going to simplify just what's under the house. So I get 8 squared minus 4 times 1 times negative 11. And what do I get? 108. Is that a perfect square? It's not, but if you didn't know, you can literally not 105, 108. Take it and see how it gave me this big, long, ugly decimal? Anytime it gives you a decimal, it's not a perfect square. Okay, if it gives you a whole number, then cool, you don't need to square root anymore. But unfortunately, we're going to have to do like we learned, and we're going to have to simplify 108. So what goes into 108? Does 2 go into it? How many times? 54. 2 goes into 54 27 times. Does 2 go into 27? But 3 does. 9 times. And then 9's a perfect square with 3 and 3. So these 1, 2, 3, 4, 5 numbers are all prime. So I'm done with my factor tree. So what are my pairs? I have a pair of 2, and I also have a pair of 3. So that's going to take that out. And then what's left? 3. So what's 2 times 3? Now, I know that negative 8 over 2 can simplify, so I'm going to go ahead and break this apart and put a plus and minus in the middle. Okay, so I get negative 8 over 2 here, and then I get 6 square root of 3 over 2 here. Because it can simplify, I'm going to separate. Okay? Now, what is negative 8 over 2? Plus or minus, does 6 over 2 simplify? Now, can I combine these? No, y'all are right. I feel like y'all wanted to say it, but you didn't. Okay, it's okay. So no, you can't, because remember, we treat this square root like a variable. Okay? So if this was 6x over 2, could we still have simplified it? Yeah. But if this is 4 plus or minus 6x, we can't combine them because they're not like. Okay, so this means our solution is negative 4 minus 3 square root of 3, negative 4 plus 3 square root of 3. So this one you definitely would not have been able to factor. So is number 3 ready to go? No. What's wrong with it? Yeah, remember, just like solving before, we have to be able to set it equal to 0 first. Okay, so I need to move this 3x, and where's it going to go? Beginning, middle, or end? Middle, because it's my b term, right? So minus 3x, and I end up getting x squared minus 3x plus 15 equals 0. And now I can find my a, b, and c. So what's a? B? And c? So then I build my skeleton. And I plug in. Okay, so 2 negatives makes a positive. 2 times 1 is 2. And I'm going to simplify just what's under the house. Has anybody typed that in their calculator? Negative 51. Now, can 51 simplify? Actually, 3 goes into 51. But 17 times, and 3 and 17 are prime. So there's no pair, so no, you can't simplify that. But what can we do? Take the negative out and put a what in front? An I. So 3 plus or minus I square root of 51 over 2. Now, do I need to separate and simplify on this one? No, because nothing's going to simplify, so you can leave it if you want. If you still want to separate it, you're more than welcome to, but you don't have to. So my solutions are 3 minus I square root of 51 over 2. 3 plus I square root of 51 over 2. Okay, there is a back. I'm not going to do all of them with you because I want you to have enough time to practice today and then also tomorrow. But I'm going to actually help you set them up because if you notice, they're not as pretty. Okay? So let's look at them. Okay, so looking at this first one, do we want fractions? No. We need it to be in proper standard form, and that's not fractions. So what can we do when it's an equation to get rid of fractions? We can get them to have a common denominator. So what's the common denominator here? Huh? 4. Okay, because we can't make 4 get smaller, but we can make 2 get bigger. Okay, so technically my denominator here is 1, and if you really want to be all the way across, this is actually over 1 as well. Okay, so I need all the denominators to be a 4. So this is already 4. How do I make a 2 turn into a 4? And what I do at the top, I have to do, what I do at the bottom, I have to do the top. That's what keeps it equal. Okay? Here, a 1, I'm going to have to multiply by 4. And so 1 times 2 is 2x squared over 4. This was already over 4. Now negative 3 times 4 is negative 12 over 4. And then equals technically 0 over 4. Now, when your denominators match, I don't know if you, dang it, remember, but you can multiply the whole thing by 4, and what cancels division? So you end up with 2x squared plus 1x minus 12 equals 0. Now, is that something we can plug into the quadratic formula? Yes. Okay, so what would your A, B, and C be? 2, 1, and negative 12. Okay, so let's look at number 5. Like I said, we're not going to go all the way through these, but I am going to teach y'all how to set them up, because plugging into the formula never changes. It's going to be just like the other 2 or 3 that we did. Okay, so what's different about this one? They're decimals. And what place are they in? Tens place. So can we multiply them all by 10? Yeah, as long as we do to one side the same thing we do on the other side, it's still equal. Well, all that does, y'all, is move the decimal over 1 time for all of it. So it becomes 2x squared plus 4x equals 3. Now is it ready? No, what do I still need to do? I need to subtract 3 from both sides. And one thing I want y'all to realize is that's a super important step, because I notice a lot that when kids don't do it, they would have put A equals B equals C equals, and they would have put a positive 3 for C. But technically, is it a positive 3? No, it should be negative. So don't skip that step, even though it seems a little tedious, because it is super important. Okay. Last one. What do you think we have to do here? We have to double distribute. Okay, so we're going to do 4x times x, and that gives you 4x squared. 4x times 2, that's 8x. Negative 1 times x is negative 1x. Negative 1 times 2 is negative 2. Okay, when you double distribute, your middle 2 terms should almost always be like terms. So we get 4x squared plus 7x minus 2 equals 4x. Now, am I ready? No, what do I still need to do? Subtract the 4x. And that's a like term with the 7x, so it's going to go under there. And I get 4x squared plus what? Minus 2 equals 0. Now, what's my A, B, and C? So I'm going to work this one all the way out. If you don't need it, you can start working on your practice. Now, make sure on your practice you realize number 1, 2, 3, and 4 are telling you to use different methods, not this. After that's all this, okay? Okay, so we're going to fill in our skeleton. Okay, and I know that this is B, B, A, and C. And I'm going to simplify just what's under the house and the other 2 pieces as well. So this becomes a negative 3. This becomes 8. And then let's type what's under the house. And that gives me 41. Which is not a perfect square, so I'm going to have to break it down. What goes into 41? I don't think anything does. You can't break it down, so it stays. And so this cannot simplify at all, so we literally just separate. And there's your answer.